Welcome for the next session of computer graphics. Today, we will see boundary fill polygon filling algorithm. For the polygon filling with particular color, we have to determine the pixels falling on the border of the polygon and those pixels which fall inside the polygon, so that we can fill the pixels inside the polygon with a specified color. There are three algorithms for polygon filling where we will see. The first is the seed fill algorithm, which can be boundary fill and flood fill. Scanline polygon fill algorithm is also used for polygon fill. Let us see four connected method used for seed fill algorithm. The blue color pixel, which is represented as the current pixel, is surrounded by four pixels, that is above, below, right and left side of the current pixel. In the four connected method, these four pixels will be filled. And in the eight connected method, this blue color represents the current pixel, that is seed pixel, along with the above, below, right and left pixels as used in the four connected method. In the eight connected method, the four diagonal pixels, that is this one, this one, this one and this one, are also colored, so that the entire area of the current pixel is covered. Let us see boundary fill algorithm. In the boundary fill algorithm, first take the position of the starting point and the boundary color from the user. Then decide whether you want to go in four directions, that is north, south, west and east, as in four connected method, or north, south, west, east and northwest, northeast, southwest, southeast, as in 8 connected method. Then choose a fill color. Then travel in those directions as selected by 4 connected or 8 connected method. If the pixel you land on is not having the fill color or the boundary color, then the boundary fill algorithm will replace that pixel's color with the fill color. So in the four connected method, the boundary fill algorithm will take current pixel, that is x and y coordinates of the current pixel, fill color and boundary color as the arguments. Then getPixel function will get the color of the current pixel specified by xy coordinates. If the color of the current pixel is not equal to boundary color and color of the current pixel is not same as fill color, then the current pixel xy will be colored with the fill color by putPixel function. Then the boundary fill function is recursively called for the four neighbor pixels, that is x plus 1 y, that is east node, x y plus 1, that is south node, x minus 1 y, that is west node, and x y minus 1, that is north node. This is explained with the example for the four connected method. So if xy is the current pixel, then these four pixels will be colored by the four connected method as shown in the diagram. Starting from the interior point xy, the south neighbor, north neighbor, west neighbor and east neighbor will be colored. In some cases, an 8 connected algorithm is more accurate than 4 connected algorithm. This is explained with the help of the diagram. In this diagram, if this pixel shown by the dotted circle is selected as the seed pixel, when the algorithm will start with this and will go on filling the remaining pixels, then finally at some point these pixels will be colored and then the algorithm will stop. So this incomplete filling will be the result of the 4 connected pixels. To remove this drawback, it is better to go for 8 connected method. So in the 8 connected method of boundary fill, the current pixel position, that is xy, fill color and boundary color are used. If the current pixel's color is not same as boundary color and current pixel's color is not same as fill color, then the current pixel xy is filled with the fill color. Then all the 8 neighbors will be colored by the boundary fill algorithm. This is represented again with the help of the diagram. That is, if this is the starting point, then these 8 neighbors will be colored. That is south node, then north node, west node, east node, then north east neighbor, then northwest neighbor, then southwest neighbor, and finally the southeast neighbor will be colored as shown in the figure. There are some disadvantages of the boundary fill algorithm. The algorithm is slow. The algorithm may also fail for large polygons. Also, initial pixel requires more knowledge about surrounding pixels. These are the few differences between flood fill and boundary fill algorithm. In the flood fill algorithm, it colors an entire area in the enclosed figure through interconnected pixels using a single color. While in boundary fill algorithm, the area gets colored with pixels of boundary color, giving the technique its name. Then in the flood fill algorithm, it can fill polygon having multiple boundary colors, whereas boundary fill algorithm requires polygon with the same boundary color. That is, if you are having a polygon whose all the boundaries are colored with the same color, that is, say red, then only boundary fill algorithm can color it. Whereas in the polygon filling in the flood fill algorithm, it can fill the polygon whose boundary is of same color, say red, as well as if the boundary of the polygon is having multiple colors like red as well as say green, then also the flood fill algorithm can color it, whereas boundary fill algorithm cannot. Then in the flood fill algorithm, all connected pixels of a selected color get replaced by a fill color, and boundary fill algorithm is also similar to flood fill with the difference that program stops when a given color boundary is found. Flood fill algorithm requires large memory, whereas boundary fill algorithm requires less memory compared to flood fill. Flood fill algorithm is comparatively slower than boundary fill, whereas the boundary fill algorithm is faster than flood. These are the few references used for the study of the topic. Also, I would like to thank those references from where the material is used to prepare this PPT. Thank you.